I talk about the three things. Okay, when that booming of artificial intelligence, machine learning, and deep learning. So this 3 years we have to remember it. Okay, so it started the process of this machine learning. That concept of human behavior to the system started from the 1956. Okay, but if you wonder it, that started earlier. Okay, there is a neural network. So I will discuss in the next slide. Okay, so that's a machine. How we can make that machine as intelligence started on that 1956. They make it the intelligence machines also. Then after that, 1956 to 1990, so a lot of statistical and mathematical data mining, data kind of algorithms. So they developed one by one. Okay, so the advancement of all the algorithm. Okay, so that is not explicitly programmed kind of learning, training, help of the machine learning is derived on 1990. Again, that concept that GPU powers, okay, so CPU is not supporting that much of computation process, so they increase that GPU's power of to utilize the algorithm in a better manner. So they derive the concept on 2010. Okay, so they make it lot of inside layers and a lot of computation power with the help of that GPUs. They made it that the deep learning. Okay, so we are doing a lot of deep learning with the integration of other discipline product on from this 2010 onwards. Okay, so this is the major timeline. So apart from that, I already told that. So 1956, okay, that artificial intelligence, that human behavior has started, but in 1940 itself, okay, that is they introduced PITS and MC. Okay, so that is a simple neuron networks. Okay, so they derive the concept of that normal electronic circuit to how our brain is recognizing. Same thing, they made it some small electronic kind of neurons, made it artificial neuron to make it that kind of automation, but it's derived on 1956. Okay, exactly that the perceptron, that is a derived by Windra and half. Okay, so they made it that Roseblot, that is a scientist, with weight for each and every the neurons. Okay, so I already told you one example to you. Okay, so if I touch, okay, in any of my hand or something, so it's passing that information through my hand, and so much of that inside organs, inside that neurons, whatever it's there from my hand to brain, passing the information to my brain. So that passing the information from that neurons to my brain with the help of that, that chemicals, biochemicals, and all those things. We can discuss these things very deeply in that unit of fourth or unit 3, I think. Okay, exactly. I don't know. So which unit neural network you are going to study? You can read it this concept well. Okay. So how we are getting the pain of my hand? Okay, same thing for artificial neuron. Okay, we are saying that is weight. Okay, so whenever it's firing to next neuron, okay, that is artificial neuron, one neuron is going to talk to another neuron. Okay, so that neuron is going to talk to another neuron. So finally, we are going to get the output. Okay, so instead of chemical passing of information here, we are passing the weight informations. Okay, so simply we can say input into weight plus the bias is the simple neuron formulas. Okay, so weight is identified by, so which neuron to act for what kind of output. Okay, so for example, if you have to identify that any digit, okay, handwritten recognition, okay, the digit is written 1. Okay, so if I have to identify that 1, okay, so I have to identify the digit 1. Okay, so if I have to identify the digit is 1, so wherever the block pixel will be there, okay, so that based upon that the weight will allocate. Okay, so then identify that weight for wherever the block pixel will be there, or wherever the white will be there, it won't identify, because that is not needed for to identify the number 1. Okay, so I'm talking about how to identify the digit 1. Okay, so as of that weight will work. Okay, so they find out, okay, how we can make it that the machines to maybe make it at the next level. Okay, that success on 1956 as for this chart. So 1956 they implemented with all the learning principle of implemented the concept of artificial intelligence, but before that they derived this concept and all. Okay, so after that 1970, okay, so what's the problem we are getting it? Okay, so generally we can solve the problem by whatever the classification. Okay, so just maybe my problem. Okay, suppose I have to classify maybe how many red balls or how many maybe that block ball. Okay, so red ball is I mentioned in the minus. Okay, so maybe white ball is I mentioned in round shape. Okay, so only two classes will be there. I can classify based upon attributes. Okay, this is the red, so this is the white ball. Okay, so I need some line to classify, okay, red ball and white ball. Okay, sometimes the white ball, maybe I classified, my machine maybe classified as red ball. Okay, so by mistake of that, understanding of that, okay, we can say this is error. Okay, this is the error of. Okay, so we can say this is the simple classification problem. I'm identifying the two objects. Okay, so one is red or white. So which color of ball? Okay, so I have to separate these two attributes separately by, okay, so that's line. Okay, okay, so some of the problems, okay, I couldn't able to separate by the single line. So it's not able to linearly separable. Okay, in this problem also it's getting problem. So how we can solve? So we can solve it by the curve line. Yes, we are using the curve line to separate this. Okay, sometimes the ball will be here. Okay, so that white ball is in red ball. By mistakenly your machinist understand, then I have to make it again the separate line. Okay, so how it will be your graph look like? Okay, so some curve line and again I also curve line. Okay, so here some red ball will be there. Sorry, white ball will be there. Here some white ball will be there. So here everything white. So you are making what? So many lines. Okay, so many lines to classify the problem. Okay, so we can say that is a multi classification problem. Okay, so that kind of concept they derived on the solving the problem of XR. Okay, so now maybe you don't know what is the XR problem. Okay, so I can try to understand. So remaining we can discuss the practically later. Okay, suppose I have input as 0, 1 and 0, 1. I'm taking like this. Okay, so your ungate. Okay, so ungate means 0, 0 means 0 and 0, 1 means 0 and 1, 0 means 0. Okay, so when ungate will fire, whenever both the output is 1. So when ungate will fire, both the input is 1. Okay, so this is the ungate output. Okay, so this is the ungate output. When it will fire, both the inputs are 1, then it will be 1. Okay, so 0, 0 means 0. Okay, so 0, 1 means 0. So 1, 0 means 0. So 1, 1 means 1. Okay, so 1, 1 means 1. Okay, so 0, 0 means 0. 0, 1 means 0. 1, 0 means 0. But whenever both the input, okay, this is x-axis, this is y-axis. Okay, so both the inputs are 1, then 1. So now I can able to classify. Wherever the 0 will be there, 1 class, and 1 will be there, 1 class. Okay, so this problem we can say linearly separable. Class separately, 1 class separately. Yes. Okay, so what is the ungate first of all? Okay, so ungate means, okay, so we have the symbol of ungate. Okay, okay, whenever in your circuit, okay, if you are giving 2 inputs, it will give 1 output. Okay, I am giving input is X, then input is Y, then what is the output of this gate is going to produce is Z. Okay, so when this ungate will work, whenever X and Y, both the input is 1, the output is 1. Both both the input is 1, then output is 1. Our remaining condition, it will be 0. Hope everybody getting this point?
Yes, ma'am.
Yeah.
Yes,
Yes.
ma'am.
So
Please,
now
please.
I have 2 points, x-axis and y-axis. So this is x value. How many values I have? Zeros and 1 of x. And maybe the possibilities of only 2 kind of input only possible. Okay, so if you use 3, then 3 we need, but we have only 2. Okay, so why? Maybe the input is 0 or maybe 1. Okay, so when it will be fire? Both the x and y will be 1. So I'm taking this is 0, this is 1, this is 0, this is 1. Okay, so when it will fire, both the inputs are 1. Okay, so x also 1, y also 1, then output will be 1. Remaining output and all what? 0. Do it on 4th unit. So now you can able to separate 0 class separately. This problem is linearly separable. Why? Because I can able to classify, okay, 0 separately, 1 separately by the single line. Understand everybody? Single line able to separate 2 classes easily. For example, we are taking the AND gate. So both the inputs are 1, then it will be 1. So I'm making the flat graph. So how this is possible? How we can do this with the help of neural network? We can discuss on your problem is solved on before 1960. See, this problem and all linearly separable before 1960. We can say that is the perceptron solved by the single line. So I need 2 line. Okay. So which gate is this one? So I taken this example is XR gate. So XR symbol is, I don't have that much good drawing of with the help of this one. Okay, so this is the XR gate. Okay, so when it will be fire, whenever 0, 1 means 1, 1, 0 means 1. Remaining and all 0.
0.
0, 0 means 0. So remaining all the condition it will be fail. Okay, so 0, 0 means 0 or 1, 1 means 0. Okay, this is the truth table of how your XR gate is working. So now again I am going to make the flat of the graph 0 and 1, 0, 1. So this is x-axis, this is y-axis. Okay, so 0, 1 means what? 0, 1 means 1.
1.
1, 0 means 1.
1.
Okay, this place exactly it's the ground. 0, 0 means
0.
0.
0. 1, 1 means
0.
0.
0.
Okay, so now I have to classify this graph. Okay, so now I want 1 line and I want another line. Okay, because 0 class separately and 1 class separately. So now how many lines I'm using? Linearly separable. Okay, non-linearly separable problem we can say. Otherwise, I have to draw in a curve line. Okay, to separate this one, I have to move on from this to this. Okay, so like this, I have to draw. Understand? Okay, so this kind of problem is non-linearly separable. It's not needed a single line. Okay, so understand, XR problem is solved on which year? Okay, so XR is one of the example. XR is one of the example. So this kind of problems not solvable by the single line. So here they solve by the single line, but here they couldn't able to solve it. So we need 2 lines. This one, 2 line. So these are the problems are solved by 1970. Okay. Then little bit, this we can say that is a multi-layer network. Okay, that is the improvement of next one. So what is this concept? So multi-layered perceptron means what? Okay, so try to understand everything little bit. Everybody written this one? They done, the concept is what? Okay, so Shall I clear the frame of this one? Yes. Okay, so multi-layer perceptron means, so I used previously only less number of node. Okay, so to identify the problem. Okay, for example, I have to identify that XR gate. Okay, only 0 class or 1 class. Only 2 classes will be there. Okay, so maybe it's I have to connect the hidden layers. Okay, don't worry about this. This and all we can discuss. So how many identification will be there? 0 and 1. Okay, so sometimes if you have to identify your face recognition. Okay, identify the face recognition. How you will identify from one person to another person? That's the problem. I need one for here. Okay, so this is the output layer. So here only zeros and one, previous problem. But here one for ears, one for nose, one for that mouth. Okay, so many classes we are doing. So that is, we can say, multi-class problem. Okay, so that is solved by on the year of 1986. That is a 1980 to 1990. So please write it. So you have to go back to your all the layers, whatever in this, you have to change lot of parameters inside that. We can say that name is backpropagation. Okay, again you have to classify. Again your machine is giving some error. Okay, so again you are training your machine. Again you are training your machine with some parameters, and now your machines may be identified correctly. Okay, so that method is back propagation. Back, you are going from the output to again input. Okay, and changing lot of parameters inside and find out what is the exact Rajinikanth is young or old. Got the concept? What is the multi-layered perceptron? Okay, that is a SVM. So SVM means support vector machine. Okay, so now I have to classify. Okay, red ball. This is red ball. Okay, this is white ball. Okay, you can make it any symbol of it. Okay, yes. Okay, so this is linearly separable problem. Okay, sometimes what will happen? Okay, support vector machine means what? Okay, so 0, 0. Okay, sometimes here that red ball will be there. Okay, in a minute place. Okay, so 1, 1, 1. Okay, so in this scenario, what will happen? I am linearly separable, but I am getting how many error here? All this error. Okay, what I am doing? I am expanding this line. Okay, expanding the line means what? I am making some mathematical things. I am just making this line is little bit with this increasing this single line with this much. We can say with the help of automatically the 1 will come here and 0 will go here. Okay, I'm telling one example. Sometimes it will go if you increase the Heiberg line. Again, sometimes it will come error. 2000. Okay, so after the 2000 to 2010, okay, so they developed the deep neural networks. So inside we are using in your layers, okay, lot of filters and all those things to solve the complex problem of it. So we have lot of that algorithms and applications. So this is application wise. Okay, so we have the linear regression, nearest neighbor, logistic regression, neural network, Bayesian network. Okay, so boostings algorithms, deep learning boostings. Okay, so I talk about only the neural network. Apart from that, they implemented the Bayesian's Naive probability, the conditional probabilities concept of this Bayesian's network, and based upon that decision trees, they increased that level of that boosting concept in this 1990 to 2000. Okay, so now SG boost. Okay, that they are talking about after the 2009 onwards. Okay, so please note down this. So again, I given that related to that other algorithms like nearest neighbor and other wise. Okay, so I taken from other sources. So you can refer this and all for you. And again, what is the timeline for extension of these things? So this and all you can refer it while I am giving you a slide. Okay, so now we are going to discuss about how the uses and abuses of machine learning. Okay, so how it will be helpful, then how it will be spoiling the things. Okay, so we discussed so many applications related to our smart home, automobile industry, social industries and business oriented applications, hospital, government, a lot of application we discussed yesterday. Okay, so your friend said that unwanted spam and segmentation of that, how we can do the advertisement or forecasting the weather. Okay, so any credit card or something, bank transaction or bank predictions, bankruptcies, things happened, and any disaster kind of things. Okay, so we are using. Okay, so there is autopiloting drones and self-driving cars. Office identify the genetic the sequence in the biological. We discussed a lot of applications. So for this, we are using a lot of where. So I have to take it that the two things that's how happened on. I think some of them. Okay, that is the deep blue. Okay, that story. Okay, so if you have time, you can study this one. I can say by one line how it's. Okay, so the famous that chess players Gary Kasper. Okay, so that mission, yes, that Gary Kasper is the world champion. Okay, so that computer is beated him, uh, and he lost the match. Okay, so this is the one scenario has happened on. So now that new things, that is the stockfish. I think. That a new term of the Leela chess zero and stockfish. So that is computers and machine learning trained. Okay, so they trained with so many humans how they played, whether the champions or maybe the players. They played that samples, that the training samples given to the machine learning, the artificial trained machines along with the normal computers instructed. Okay, so they done the competition of with both the systems. Finally, the stockfish won that match. Okay, so everybody wonder that one. So if you have time, so you prepare the case studies on tomorrow. Okay, so about the stockfish, how it's beated the computers. Okay, so this is the another things. So everybody heard about again the surveillance systems of China. So how they control the people with the help of that COVID-19 surveillance system. So these are the some famous success. Okay, so I'm talking two, three things to you, and you can bring it. So again, flop of things. Okay, so sometimes it's our voice recognition. Still, the Googles are facing the problem of that voice recognitions and struggle of to answer the questions of that whatever we are expecting from that. It's not identifying. You have